So open up a brand new Flutter project and let's delete everything below the main function so that we can create this from scratch. Starting with a stateless widget, inside the material app, let's create a homepage called homepage.dart. And for the homepage, let's make it into a stateful widget. So we should just have a blank scaffold inside. Let's start by changing the background color to a little bit of gray. And in the body, let's create a column. So just a little plan here. Let's create at the top just some numbers. So the game stats and the menu. In the middle, we'll have the grid. And at the bottom, we can just create some text for some fancy branding. So firstly, let's create a container with a color of gray and let's give it a height. Now what I want to display here is just some text widgets displaying some numbers. And the first one is just the number of bombs in the game. Let's copy this, and the other one is just the amount of time that's been going on since the game started. And in the middle, let's create a little button so that the user can refresh the game and start from the beginning. Awesome, now let's come to the middle section and create our grid view builder, which I created a separate quick tutorial for the grid view widget if you want to check it out. But basically here, the sliver grid delegate with fixed cross-axis count. Let's set this cross-axis to be 5. And the item count, let's say we want 25 boxes. And when we use grid views, we have to give it a height. So let's just wrap it in an expanded widget. And each of these boxes, let's give it a padding so that we can actually see. There we go. Now I don't want this to be scrollable, so in the physics, let's specify this to be never scrollable. And now instead of hard coding these numbers in, let's use a variable. So let's come up to the top and create a variable called number of squares and a number in each row. And let's make it a 9 by 9 grid. And now these blue boxes, let's separate this out into another file just called numbered box. And let's call it my number box. And instead of blue, I just want this to be gray. And now we can come back to the home page and import this guy in. Let me just tweak some of these colors. And finally at the very bottom, this is optional, but I'm just going to put a little text widget just to make it look nice. Now we need a way to know the status of each square in terms of if it's revealed or not. So the way I want to structure this list is the first part of the list has the number of bombs around that particular square, and the second part of the list stores whether we are revealed or not. For example, a particular square could have 2 bombs around it, and currently it's not revealed, so it's false. And so we're going to have a status for each square in this grid. So let's create a initial state. And so when this app gets run, I want to do a quick for loop going through each square and just make the initial value 0. So each square initially has 0 bombs around and it's not revealed. Cool, now what we also need is a list of integers to specify the bomb location. So just to make this a bit more clearer, if we go to the number box file, I'm going to create a separate variable called child so that we can pass this through from our homepage. And what I want to pass through in the child is the index, which is an integer. So let's make this to a string. And so this way you can see starting from 0, we have all the way to 80, so that's 81 numbers. And so you can pick any of these numbers to specify where you want the bomb to be, right? So for example, 4, 40, and 61, that's where I want the bombs to be. Now let's create another file called bomb.dart, and this is going to be very similar to the number box, so I'm just going to copy it in from the other file, but just make it all my bomb. And for the gray, I just want to make it a bit darker, that's all. And so when we come back to our grid view, instead of just returning a numbered box, we're going to check if the current index I'm looking at is part of the bomb location, then let's return my bomb. Otherwise, just return the numbered box. So if I save this, you can see those numbers that we specified for the bomb, they have a darker color. Cool, and while working with the number box file, let's also add a boolean called revealed. And so this will be if the user has clicked on this box or not yet. So now when we come back to the home page, we can also pass through for each individual box the status of whether it's revealed or not. Cool, so now that we know if the current box is revealed or not, we can actually play around with this and say for the color of the container, if it's revealed, I want the strength of the gray to be 300, and if it's not, the strength of the gray to be 400. And let's change the background color to be gray with a strength of 200. Awesome, and this calls for one last final feature in this numbered box, which is a function. So let's wrap this widget with a gesture detector, and on the on tab, we're going to perform the function that we create in the home page. So I'm going to do the same thing for the bomb file. And now in our home page, we can specify what happens when we tap on the screen. So in here, if the player taps on the bomb, then the player loses. And if we tap on just a normal numbered box, we are going to reveal that current box. Cool, now let's call this method reveal box numbers and come to the top and create this method. And we actually want to know which box we're currently looking at. So let's pass through the index. And so when a particular square is tapped, let's change the square status to that particular square to be true. Remember, this square status list tells you about the number of bombs around this square and also whether we are revealed or not. So we just want this revealed to be true if we tap on it. And if I save this, you can now see when you tap on a particular box, it changes color. Okay, now for the really important method, I'm going to call it scan bombs. And so basically we have to go through every square and check around this square how many bombs are present. So this is the essence of MINESWEEPER, right? Each number that we see on a particular box represents how many bombs are around this current box. So what we're going to do is use a for loop, and we're going to go through the number of squares, and let's create this integer called number of bombs around, which at the beginning, let's just say that there are no bombs around. And if you think about it, each particular square, we need to check 8 squares around it. So if you pick a particular box, there should be a maximum of 8 surrounding boxes. So for example, with a given box, let's check the square to the left. So let's create a simple if statement and say, if we're looking at position I, if we say I minus 1, that's going to be the box to the left hand side. And we're just going to check if that number is one of the bombs. And if it is, then let's add to our number of bombs around. And by the way, if you're not familiar with this plus notation, what it means is number of bombs around equals number of bombs around plus 1. So it's just adding 1 to myself. So plus is a nice shorthand way to say this. And what we want to do is we want to run this scan bombs method at the very beginning. So let's put it in our init state function. Now, one caveat to this when we check for bombs that are around, if we're checking the square to the left, we only want to do this when we are not on the very left column. So if you're on the first column, then there is no left to check, right? So we only want to check the square to the left unless it is in the first column. So I'm going to add in another condition here. So I modulus number in each row is not 0. Now, just to make this very clear and simple to understand, I'm going to go down to the numbered box when we create it in our grid. And instead of just printing the index, I want to print index percent number in each row. And so what this percent does is it's called the modulus, which basically tells you the remainder. So right now you can see the numbers in our grid go from 0 to 80. Well, what's the remainder if you divide by the number in each row, which is dividing by 9? So if I save this, you can see that in the first column, the remainder is all 0, second column remainder is all 1, all the way through to 8. And so this is really useful in identifying which column that we're currently looking at, right? So if we come back to our scan bombs method, I percent number in each row is not 0. This is just ensuring that we are in any column but the 0 remainder column. Now similarly, let's check the square to the top left, unless it's in the first column or the first row, because we're checking in 2 directions now. So it's going to be very similar, but if we're checking the top left, that's subtracting 1, and then subtracting a whole row, right? And we want to make sure we're not in the first column or the first row. So we already talked about this condition. Now this extra condition that we just added, I is greater or equal to number in each row. This just ensures that, again, if we just go back to the index for each square, number in each row is 9. So what this is just ensuring is we're at least 9 and above. In other words, we're not in the first row. Cool, so let me know if you have any problems understanding what I'm doing here. I'm happy to answer your questions below to clear things up. But basically we have 8 directions to check, right? So we just checked the left, top left. Now we can check the top right, the right, bottom, bottom left, and that's it. That's 8 directions for each particular square. And once we've found all of these bombs around our square, we can update our square status list to jot down how many bombs are around a particular square. And this number I, we're starting from I equals to 0. So we're just starting from the very first square and then checking every single square using this for loop. So of course you can check out this code from my GitHub below to get a closer look at this, but hopefully the idea made sense and you followed along. And so now in our numbered box in the child, instead of just returning the index, I'm going to now return how many bombs are around. So square status index and 0. And you can see the code works. So 0 is if there's no bombs around, and if there's a bomb around, then you got the ones surrounding that bomb. Cool. And if it's a bomb, we actually don't need a child. Let's just say X. And if you want to add more bombs, then you can come to this bomb location and just add whatever you want. And so if I add one right next to 4 and say number 5, you can see that the numbers change to 2 because there's 2 bombs surrounding that particular box. And 3 and so on. So this is how MINESWEEPER works. Okay, so now let's play with the revealed aspects. So we only want to reveal when we click on it. Right, so if we come to our number box file, if it's revealed, then return the child, otherwise return nothing. So if we save this and click around, now it should work much better. Now when it comes to the bombs, either all of them are revealed or none of them are revealed. So in other words, if a player clicks on a bomb, then you lose the game, right? So at that point, we want to reveal where all the bombs are. So when it comes to the bombs, we just need one boolean. Let's just call it bombs revealed and set it to be false. And if anyone clicks on my bomb, then let's set the state and change the bomb revealed to be true. And if we just save this, if I click on a bomb, yep, all of them get revealed. And then later we can just add here a little show dialog just saying game over or something like that. Now the other crucial feature to fix for this game is if you click on a number, like if you click on a box and it's a number 1, 2, or 3, then only that box gets revealed. Whereas if you click on a box and it's 0, it reveals that block of land essentially of all zeros. So if we look at our reveal box numbers method, let's reveal the current box if it's a number that is 1, 2, and 3. So in other words, if it's not 0. And if it is 0, then let's create an else statement. An else statement should get the job done, but just for clarity, I'm just going to put an else if statement and say if the square we're looking at has 0 bombs around, we want to reveal the current box. We also want to reveal the 8 surrounding boxes unless you're on a wall. So let's set the state and reveal the current box as well as the surrounding boxes. So let's just start with revealing the left box first, unless it's currently on a wall. So as long as I'm not in the first row, and the left box that I'm currently looking at is not revealed yet, and it's also a 0, then I'm going to recurse this. Meaning I'm going to run this exact same method, reveal box numbers, but instead of index, I'm going to put in index -1. And then after that, let's reveal the left box. So this idea of recursion, basically what I'm doing is if I click on a particular box and it's 0, then it'll move on to the left box and check if that's 0. And if it is, then reveal that, and it's going to continue on until we hit the left wall. And so you can see here, if I click on a particular 0, it's just going to reveal everything to the left-hand side. And so this is only the code for looking at the left direction, but we also want to look at all 8 directions so that effectively we kind of explore around so that we kind of hit every single wall and reveal everything within that wall. So again here, I wrote these comments so that I can help make it as simple as possible, but if you have any questions, just let me know below and I'm happy to answer any of these questions. So this is just for the left direction, and from here I'm just going to copy in a bit of code because it's the same idea but for the left box, for the top box, for the top right, for the right box, for the bottom right box, the bottom, and finally bottom left. So essentially what this does is, it might be more clear if I add some more bombs here. So we want this sort of behavior. Yep. So if you click on a 0, it fills up and explores until you hit the walls. And this was the hardest part to figure out for me when I was trying to make this. But let's just make this a little more prettier. So in the text, I just want to switch up the colors. So if the child is 1, then let's make it blue, and otherwise let's make it red. And if it's 1, it's blue. If it's not, let's put another condition here. If it's 2, then let's make it green, which means if it's 3, that will make it red. And the other thing is, in MINESWEEPER, they actually don't print out the zeros. So yep, that looks much cleaner. So if I just change up some of these bombs again, you can see if I click on a space that has no bombs around it, it will explore and fill up all of the space until we hit walls. Okay, awesome. Now we actually know how many bombs will be in a particular game. So instead of hard coding this to be 6, let's say bomb location dot length toString. So there's going to be 7 bombs in this game. Okay, so the mechanics of the game is pretty much all done now. Now let's just add some finishing touches, like a condition for the player to win and lose the game. So starting with player losing. If the player loses, then let's return a alert dialog, which I also made a short Flutter tutorial for, so check that widget out if you need. But basically, if I click on a bomb, then I'll print this message saying you lost. And let's also give a button that allows the user to play again. So if we press this button, then we want to restart the game, which is a method we haven't created yet. And we also want to add this bit of code, so navigator.pop. So this will just get rid of the alert dialog once the user clicked on it. And let's also come to the top and create this restart game method. So let's set the state and just set some of the values back to the original. So bombs revealed is 0. Do a for loop through every square and just change the revealed status back to false. I can't see the refreshed button. Oh, there it is. Let's give it an icon. So I want to give it the refreshed icon. Cool, so we have this restart game method, which means we can actually wrap this card in a gesture detector, and we can restart by clicking on this button as well. Okay, so that's when the player loses. Lastly, let's figure out when the player wins. So how do we know if the player wins? Well, let's check how many boxes that the user has yet to reveal. And if this number is the same as the number of bombs, then the player has won. So basically they've revealed everything except for the bombs. And we want to run this check winner method every time that the user taps on a square. And so if the player won, then let's show a similar alert dialog. For the player won alert dialog, I'm just going to copy it in because it's so similar to the player lost one. But now if we save this and play the game, everything works as planned. Cool. Now, from this point on, a couple of things that you could do is a way to make the bomb locations random every time we refresh the game. And also we could work with the time as well. So in the actual Minesweeper game, when you start playing, it also counts how long you're taking for each round. But in terms of the actual gameplay and the mechanics of Minesweeper, this should do it. So hopefully you learned something and that was easy to understand. Let me know if you have any problems, but other than that, thanks for watching and I'll catch you guys in the next one. Laters!